Hello students, I hope you're having a fantastic day. In this video, you'll be taking our second full TOEFL IBT listening practice test. Now keep in mind, there will be 5 audio recordings, 3 academic lectures, each of them 4 to 5 minutes long, and each lecture will be followed by 6 questions. Then there are 2 university-based conversations, each of them about 2 to 3 minutes long, and followed by 5 questions per conversation. ETS says it'll take you about 36 minutes, but most students take between 40 and 55 minutes. And don't forget to take detailed notes for each lecture and each conversation. Now, there will be a timer on your screen for each question, but keep in mind that on the actual test, you will be in control of your time. But for the purposes of this video, I want you to practice your timing. So you'll have 40 seconds per question. If you haven't already, I recommend you check out our complete TOEFL course video on YouTube, which gives you a detailed introduction to all 4 sections of the test. And if you're really serious about your TOEFL preparation, I suggest you take our online course, Unlock the TOEFL IBT Mastering the Test. It takes about 25 hours to complete and goes in depth into every part of the test. More details about the course are at the end of this video. And as always, click on the link in the description below if you'd like to download the PDF with answers and explanations for this test. Okay, students, without further ado, let's get started.
Okay, everyone. We've spent the last few sessions talking about the classification of clouds, cumulus, stratus, cirrus, and the atmospheric stability conditions that create them. But today, I want to shift gears and tackle a question that might seem simple on the surface, but is actually quite complex. How exactly do clouds release water? In other words, how do we get from a fluffy cloud floating in the sky to actual raindrops falling on your head? You might think, well, gravity just pulls the water down, right? But it's not that straightforward. First, we need to remember that clouds are made of microscopic water droplets or ice crystals. These things are tiny, about 10 to 20 micrometers in diameter. To give you some perspective, a typical raindrop is about 2,000 micrometers. You would need to combine roughly 1 million cloud droplets to make a single raindrop heavy enough to fall to the ground without evaporating. So the big question is, how do these